Uh, 756, pyramid transition matrix. We're stacking blocks to form a pyramid. Each block has a color, which is a one-letter string. We're allowed to place any color block C on top of the two adjacent blocks of colors A and B, if and only if ABC is allowed tripled. Allowed triple? Anyway, all right, I'll read it again. We start with a bottom row of bottom represented by a single string. We also start with a list of allowed triples allowed. Each allowed triple is represented as a string of length 3. We turn true if we could build the pyramid all the way to the top, otherwise false. Okay, we have to read it. So basically, a triplet is... Okay, BCD is at the bottom. Then we stack stuff on top. Okay, so it's not actually a tree. I'm just reading this in a weird way. There's a BCD, and then we could stack them on top. Top of two adjacent. Okay, so I mean, isn't it just simulation? Or am I missing something? Oh, because you could have multiple colors. Okay. Because this is okay. So there's only 7 things in the set apparently. We'll have a length in range. So there's 200 possible things. Okay, just to be clear, so the order matters. Okay, it's like a graphy thing. Bottom with a string with length of 2 today. Okay, I think it seems like the core of this problem is going to be try to figure out. I mean, I feel like it's probably some sort of recursion thing, and we have to figure out what the max kind of thing, like the max running time would be. Okay, maybe we'll see. But basically, okay, AA. So then you construct a second string. Then we could choose either A or B. Note that they could be allowed tripled. A, B, and C, and A, B, D with C is not even a D. What? What does that mean? Oh, well, that you could have multiple different ones. Yeah, no, I got that. I think. Can we just do recursion? So how many possible things are on each stack? Yeah, I mean, I'm gonna try to. I mean, I think that's just my general hunch. Um, excuse me, sorry. Uh, okay, I'm just pulling out my calculator so that I could kind of figure out some of the maths. 200. What does that mean for me? Does that matter? I mean, I think that restrains the number of possible worst case a lot, for sure, instead of like an open allowed thing. It feels graphy, but the nature, the structure seems very like DFSE. But okay, fine. Let me try it out. So the bottom have it could be half a length of 8. So the one on top of that is the length of 7. So 7 and only 7 possibilities. So what's 7 to 7? 82 possible strings. Not all of them is going to be possible because you only have at most 200 in the next one. I mean, I think there's going to be some natural pruning, but I think you could do recursion because maybe, why not? Yeah, it's a little expensive though in the worst case. But especially if you do something naive and uh, try all the brute force ones. Okay, well, if it's not recursion, can we do it backwards? Can we figure out what is on top of the pyramid? Now, the proper pyramid is the top of the pyramid is C, for example. What does that mean? In this case, maybe this is an actual example. So A will force a G and a E. But that's fine, but you're going to have that recursion with the top have multiple possible bottoms. Oh. People don't like this problem, apparently. I think my thing is just think about like in a case where like a lot of stuff is just all A's or something, or the similar characters. So your branching factor is going to be huge. Because I also think that maybe you could kind of construct a thing where the recursion is based off the last letter, so you could kind of limit stuff this way. Like if the previous letter is G, then you can only have a Y. But if you have like all A allows, then maybe that doesn't matter. Or like that doesn't shorten anything. That is a curious one. Let's do. Well, I mean, maybe it's recursion of some kind of cache. Maybe. So this subtree or subpyramid has a result if no, because you have to combine them later, right? Is that weird? Maybe it's weird. Because this C has a contribution to both things. I don't know. I'm not sure it's not brute force, but can't prove it to me yet. Maybe I'm not analyzing the worst case yet. I also think hmm, okay, I think maybe I have an idea that based off the fact that the alphabet is only 7. So then for each space, we could store the possibilities and then kind of maybe brute force the next possibilities and then go on that way. And because each alphabet, so there's only was it 2 to the 7 possibilities, then that's only 128 for each cell. So then that allows, so like a weird dynamic program. I think that's what I'm going to do. Maybe we could look at the degree of colors engine or something like that. Yeah, but I don't. Yeah, maybe there's something with like more graphic, but I think a smart brute force is kind of what I'm going to do. Because because it's 2 to the 7, right? So 2 to the 14 is 16,000, which is good enough for each level. 16,000 times 5 up to 8. So I think that should be okay, actually. I know I'm hand waving a little bit, but basically I think each cell should just contain the bit mask, and then you kind of build the bit mask up, and then and because there are only 7 possibilities, so that's actually I did the math wrong. I did 2 to the 7 times 2 to the 7, but actually it's less than that. It's just 7 times 7. Uh, if that makes sense. And then you kind of keep on building the previous level. I think I got it. I'll explain it if I if it's actually right, but which isn't necessarily guaranteed. But okay, cool. Okay. Let's start. Excuse me. Okay, let's just start with count. Oh, I'm gonna use Python actually, but just realized I was using C++. Okay, so for allowed and allowed, list. Okay. Yeah, okay. I could use a base 7 number even, but what's it called? Just it. Okay, I'll use a function. What am I doing? D 2. That's 2, right? Okay. Say this one was a more mouthful than I did. How long did it take? 10 minutes to analyze it. That's probably a little slow. Maybe okay. It's fine. It is what it is. You can only do the best you can, and the rest we'll just figure it out. You can actually make this base 7, but it doesn't matter because we're putting in a hash table. Okay. Period. Okay, so that's building the adjacency list, essentially, kind of. Maybe that's not the right terminology for this one, but I always think of stuff in graph theory. Graph theory is so fun until you have trouble with it and then you curse it like I usually do. But okay. So bottom, okay, we built a bottom mask. Previous mask let's just call is equal to say that times bottom. Let's just say, oh man, this auto complete. Okay, and for bottom counter and bottom, we this mask is equal to int of char, the big mask version of it. Oh no, what am I doing? That's what I mean. Okay. Okay. And then now we spend. What does that mean? Okay. Previous mask is greater than 1. Maybe just mask. I don't call previous mask. Masks. Okay. So now we go for each cell, 2 adjacent cells. So for x is equal to x1 from 0 to the mask. I should cache that actually. But what's this masks? And it's minus 1 because we want okay. So now we got next masks. Yes. So now we're looking at x and x plus 1. Next mask is odd. That's not true, but some function of mask and mask. X and put in a helper function somehow. But what am I looking up? Oh, D for the adjacency list. Okay, so this would give me 2 adjacency lists. Wait, what? Yeah, okay. So if that got index, let's do index is equal to that index. Oh wait, now I have to iterate. No. Sometimes bit mask always get me like a little confused. I have to kind of make sure I'm looking at the right thing. So that's the index in D. If wait, yeah. Okay, now we look at the adjacency list. If index not in D, that means we don't have any edges at all from this. So then we could just return false, I think. If index is in D, then edges is equal to D index for edge and edges. Yeah, next mask x is equal to yeah, okay, 1. Yeah, I think that should be right. Maybe. Well, no, that. Oh yeah, no, that should be okay, kind of. But the premise is wrong because this is all wrong. We have to do the bitwise thing on this. Okay. Because right now we just assume it's one number, but it's actually bitwise for some reason. Well, I don't know why I did it that way, but okay. So for what do you call it? Whatever. Left in I just do 7. I probably could do something smarter, but that's for one of each of the things. Also, I think this is just wrong. But it's good that I caught it. Also, good that I have a helper function. This case, not so much though, but oops. Did I do that in anyone else? No, okay. Okay. Well, let's check that first. This mass of x and love. If this is bigger than 1 or bigger than 0, then we check the right one. X plus 1. This is greater than 0. Then we do all this stuff. It's very indented. Maybe I should have help. Now then we get the index of the left and the right. And then we do all this stuff. Okay. Did I return anything? Nope. Let's make sure we return this. Okay. And then now we just set mask is equal to next mask. This returns true, because then by then mask should be 1. Okay, well let's see how it goes. Maybe oh, this is collections. Oops. Also have to figure it out. I think maybe this is a little too weird. Oh, this is definitely wrong. Okay, because that should be okay. We can one. Oh, I guess in that case, then we have to check that some of them are not 0. Yeah, okay. Well, in this case, I think we just need to check the last one. Oh man, I did it backwards. I have to do it in other places too. Languages. Okay. That's how I do. Oh no, it's the what's it called? Oh, the okay. Is that gonna work? Let me know if there's a easier way. I feel like this is very verbose, but I also I don't know. Sometimes I'm with some, especially with Python. I feel like there's so many cute little ways to do things that I sometimes don't pay attention, or like I don't know enough to know how to look them up. But thanks. Okay. Which one? Mm, no. Wait, what? Why is this only one? Oh, because I assumed 2 characters, not. Hey, what am I doing? Oh, yeah, okay. Messy code. Okay, I mean, always easier when your base case is easy, but we'll do 6, 7, 8. Maybe something like this at least. That should be okay, because you could just keep on having A's all around. We'll see if the timing is okay. Yeah, I mean, I expect that to be true though. It's sad that my answer is false. Um, but, I mean, one's fast enough. um, yeah, maybe this is not true actually. Because it just means you don't pause to left and the right. I think that's why. My initial, yeah, okay. My initial conception was that was true false, but by because I could choose another one. But my initial one was that I only chose one character. Yeah, it's a little weird, but okay, cool. Good thing we tested it. What else is there? Is there anything funky to do? Rather than performance, I think that's. I mean, this went pretty okay for 8 things, even though it's not as well. For each one, you could, in theory, branch twice. So in theory, that's already a little bit slower than the naive recursion. Um, excuse me. Okay. Yeah, I'm just gonna submit. Cool. Cool. Wow. Whew. That was a little. Yeah, I mean, I think so. Yeah. First of all, clearly, I was definitely wrong with the recursion. I think that's just something that I don't know. When I see a tree-like thing, maybe that's what my mind gravitates to. How long did I take on this one? 24 minutes, 25 minutes. Maybe it's okay. I don't know. It's a little slower, but and I have to really talk my way through it a little bit. And end up not being that much coding, so 30 minutes. Uh, yeah. So I'm trying to think if I could like visualize this a little bit better. And I still don't have a whiteboard set up. One day I will. um, but yeah. So basically, yeah. So but I think the one point that I was on that I got right, I guess, in my initial intuition is that it's going to be just figure out what the like analyzing the worst case, or not the worst case, well, analyzing the bounds of the problem, and basically essentially, I mean, I don't think I would call this dynamic programming, though you could make it's just like very brute force, but in a way, I don't know. I don't think I call it dynamic programming, though maybe you can argument, but that's just semantics. So I don't think it matters that much. Um, the key thing to note is that from letters A to G, there are only 7 letters. So there are, so what's 2 to 7? It's like 128 or something. So what's my calculator? Yeah, 128, right? So that means for each cell, there's only 128 possibilities, right? Um, and so even on the last row, I mean, well, on the second to last row, say, so you have 7. So the bottom row have eight. Your bottom row has 8 characters. Your second to last row are going to have 7 characters, right? And each of them has 128 possibilities. So that is only 900-ish possible things to do. Um, and basically, and what I did was use a bit master. Maybe that's not necessary per se, but it's just more, I don't know, for me a little bit more intuitive. But basically, let me try to type it up in the comments. And let me know if I could visualize this better. Definitely is a tricky problem. um, but basically, the idea is that, say, so you have some, let's say you have a bit set of, possible. You could almost think of what I did, which is not quite. Just basically for each cell, for example, you have, let's say you're on the bottom, you have this thing on your bottom. Let's just add a couple more A's just for fun. So now you have 8, and then you have, let's say you have this thing as your possible transitions. So what I do is I try to, well, let's break this into array just for a little bit clarity, so, for a reason that you'll see in a second. Hopefully. I mean, I'll explain in a second whether it's understandable or it's not is another story. But well, we look at the first 2 A's, right? Well, what's the possible first element of the second of the 7th row, I guess, or second row from the bottom up? Given I'm writing them, okay, fine, I'll write them on top just because it's slightly easier. But in this case, it could be A, B, and let's just even add. I think I did a test case here. Let's just say AAC, right? So in this case, it could be A, B, and C, right? I think, is that clear-ish? I think that's understand because you have A and A on the bottom. So the possibilities for the first item is A, B, or C. I think that's understandable-ish. And then similarly for the second one, you have A and B. So you have A, B, and A, right? Oh, sorry, I don't know why I said it like that. It's just A, B, A. So the second possibility is A. And then you have more A's, so I'm just going to cut, well, BA first. So BA could be C, and that's it. Maybe I'll add one later for more declaration, for more readability, or just going through the problem. So you have someone like this, one more, someone like this, right? So that's my second row of possibilities. And actually, you could probably, yeah, you didn't need to do all the things that I did. Now that I look at it this way, is you could probably just literally write what I'm writing down now as an algorithm. And that'll probably be way easier than to understand. I just kind of did it in a way. I'll explain my solution, but you could actually just code what I did without, I would say, optimizations that I did. But now, you basically what I have here, which is the for left and the for right, in a weird way. But if you have this representation, it's actually even more straightforward, right? It's just, well, let's check A. Well, and I'm fudging it here for a second. yeah, let's just say this second thing is AB, right? I'm going to fudge it a little bit, but it just means, okay, now you're matching AA, give me all the results, AB, give all the results, and then BA, give all the results, BB, etc., and CA and CB, right? So these are kind of like the, the concatenation, the possibilities, right? So because there's 3 elements on the left and 2 elements on the right, so you have 6 possibilities. And then we just kind of take the the results of all these 6 things and then put them together. And again, you remove the duplicates and stuff like this. But essentially, that's what you would do. So you get some other string, probably ABC in this case or whatever, or something similar. And then you just kind of keep on going until the top when you could check to see if this is possible. If like let's say somewhere along the way you're trying to combine A and C, but there's no A and C in this thing, well then you're just going to end up with an empty string, right? And that's when you probably return false because you can't build on that. And for me, I just actually keep on ignoring it. I don't even terminate early. I just kind of keep on constructing these empty strings, kind of in a weird way, until I go to the top, and then on the top I'm like, oh, is the top an empty string essentially? And if it's not, then it's true. And if it is an empty string, which means that somewhere along the way it wasn't possible, right? So that's kind of the explanation a little bit. You can actually code this up. You may have some edge cases and stuff like this, but that's the thought process, right? Is that okay? If that's okay so far, then I'm going to explain what I did a little bit. Is that, and some of this is actually based off kind of how I did the analysis. Yeah. So basically, this is kind of like how do you prove that this doesn't, grow in I don't know, some kind of combinatorial explosion type thing? And the answer is it does. But the thing is that if you do the deduping and say sorting, just to kind of have a normalized way, then you have, because your alphabet is only 7 and you dedupe, so there's only 2 to the 7, which 2 to the 7, which is 128. So there's only 128 possible strings here, and each of yeah, and as we talked about earlier, this is just at most 128 times 7 or something like that. Yeah, and then here we just kind of, instead of storing it as kind of ABC, you could think of, I just converted to a bit of, well, what we call a bit mask, meaning so basically you have a number from 1 to 128, which is a binary or a 7-digit binary number. So you have 3, 4, 5, 6, 7, and you have, let's say, another random binary number, because that is not interesting. It is just randomly written. But what that means is that I think actually, in theory, in my code actually is the reverse. But for illustration, it doesn't really matter which way, because you need to, as long as you're kind of consistent about it. What is dedupe mean? Dedupe means like in theory, let's say along the way you have something like, I mean, it may even come up here. Let's say your bottom is, or your second to bottom, because you can't have a bottom with multiple, but you have ABC, ABC. In theory, you could come up with something that like is maybe like AA, BB, CC, and then dedupe is just deduplicating it. Thanks. Yeah, definitely helps. But in this case, then, well, you don't need to know that you have 2 ways to get to B or 3 ways to get to A. So you could, what we call dedupe is just short for deduplication. So you just remove all the duplications. So that converts this from this thing to ABC, right? Hope you understand. Yeah, so it's basically just a bit set is how I end up doing it. And you could kind of match this up where if there's a 1 in that digit, that means B is in the set. So if I have ABC, for example, one way that I would have it is actually something like this. And that's how I actually do it here. So something like this, right? So that's how I essentially do it. I mean, I think how I actually do it, I have my least significant digit is tied to A, but essentially that's the idea anyway. And basically, in the beginning, so this I just converted from the fixed, 1 character thing into just a bit mask that has only one true bit, and then yeah, and that's kind of the rest of the way. Uh, and yeah, I mean, I think now that we talked about it, maybe and I think you could get away with time complexity wise with kind of generating order, the string, and then just keep it a string, but make sure you do dedupes and stuff like this. Um, but I definitely was thinking more about because that's the way I thought about how big these things could be was 128, and well, how can you represent them? Well, let's just do a bit mask. I mean, that's the natural thing for me. But you don't have to. It seems like in this problem, I could be wrong. So let me know. Because my problem is only faster than 70% of people, even though I think that's roughly right. I mean, I could have terminated earlier a little bit, but I'm not gonna worry that much about it. Um, yeah, because I think I could have checked next mask here or something like this, like here. You could check if next mask is at 0 or something like that. But yeah, but that's how I would describe this file. And I think, whew, all right. Let me think. I mean, uh, if y'all have any more questions, I'll definitely answer them for kind of the problem explanation. And then I'll describe the problem in terms of how I think about it as an interviewee for a second. Let me uh, get a sip. Um, cool. Yeah, I mean, I think in general, I don't like these kind of problems in the sense that uh, I don't like things that require you to um, analyze the constraint that tightly, because it's just a very specific problem in that sense. It's just like I like maybe it's interesting-ish, but I don't. I mean, I would not. It's not my style to ask bitmasky in out stuff because there's a lot of and then you deal with like efficiency. Like, is it okay to use like in C++ or some other languages? You have like a set variable, or sorry, a set class or collection class that you could use, and sometimes that's like obviously orders of magnitude slower than using bit masks, uh, but conceptually they have the same complexity. I didn't talk about the complexity. Well, maybe I should talk about that then. Um, but but yeah, and I don't like the 2 to the n type stuff because I don't know. It just forces you to be like, oh yeah, this only works for a very specific case. Where like for an interview, like maybe that's fine, but I rather almost like I I, I almost I rather ask a candidate like problems that people could solve with or not solve in that case, but like have an approximate solution for it than having someone having the optimal solution for some like weird for like for n is less than 5 or something like that, right? Like that's just almost like a gotcha. It's too naive a little bit. But that said, like I mean, and yeah, I think that's kind of my philosophy, if that makes sense. Like I rather ask someone like, oh, uh, some kind of strategy is like, can you prove the worst bounds? And you could do like an approximate algorithm to some like really complicated stuff. Then this kind of stuff where like it only works when the alphabet is less than 8 or something like that, or 7 in this case, or I mean maybe not 7, but like for like very small n's, then it's less interesting for me. Especially talking about follow-up questions. Maybe we could have follow-up questions this one, but like what happens if you have a huge uh, 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 like a huge what you call it, huge alphabet, right? Then the math is a little trickier uh, to solve it. But yeah, I don't know. That's how I feel about it. So, but I don't know. I in my experience, I don't think I've. Well, I mean, in my personal experience, I definitely have not seen someone ask me a question that required some kind of 2 to the n bit mask bit set type thing. Yeah, you could do it in yeah, I mean, I wouldn't be surprised. I think like now that we kind of yeah, I mean, I think you are right that we could have solved this with that first search. I think uh, yeah, you could have definitely. I mean, I think, like I said, the hardest part is kind of analyzing the complexity. Because then you could, without looking at a solution, then you could just keep track of kind of the role you're in, the last character, and each of them has 128, which is essentially what we're doing anyway. And then as long as you kind of do the dedupes, then that forces things to be way easier. So, so yeah, I mean, yeah, and then as long as you do rows at a time, I think maybe something like weird, but but yeah, um, I don't know. I mean, I feel like they're also like just more straightforward problems that test certain things. For me, I probably could clean up a lot of this code. uh, I mean, but I also feel like when you do bit mask stuff or bit set stuff, it's always going to be a little tricky to clean up the code sometimes because if you want readable code, you're probably not doing bitwise stuff as that often. Ideally, I mean, not well. I mean, like if you have to, then you just write that with comments. But I think it's very rare. Um, I think in certain languages, even like maybe C sharp is one of those languages where bit set gets optimized with like a list of integers instead of like a vector of bits or something like that. But anyway, uh, yeah, cool. Let me take a look at this. Uh, cool. Wow, that is way cleaner than mine. But yeah, yeah. I mean, I think, yeah. I mean, I think the code is not like, and definitely the easier ways to. I mean, that was a very clean way and easier way. I think the hard part is kind of like, for me anyway, for this problem, is to prove yourself that like the brute force is good enough, which because I was having trouble thinking about it the right way necessary. Even though I knew it was 2 to 7 here, but yeah, I mean, I think it's okay. uh, but yeah, cool. I think